Hello everyone, welcome to this stream. So today we will be playing around with the iCEBreaker bitsy that we assembled on the last stream, right? The time flies. If you remember, the iCEBreaker is this FPGA development board. So that's an ICE40UP5K FPGA supported by the open source tools. And this board has an FTDI chip for programming and serial interface to the FPGA. It has 3 PMOD connectors, so you can connect different peripherals. It has flash and whatnot. So that's the original iCEBreaker full size, as I call it. And last stream we assembled the iCEBreaker bitsy, which is this guy. That's designed by Jordi Rodriguez. He designed this board based on previous designs. This is now pinout compatible with the Teensy, which you might know. Teensy is a small Arduino, like ARM-based Arduino board. So ARM meaning it's an ARM Cortex core, and Arduino runs on this, where normally Arduino is associated with the AVR platform from Atmega. The Teensy is a much faster core from ARM, and there's also this format version of this. The cool thing about this form factor is that it would be compatible with the socket. So this is I have a old school chip socket here, and this is a ZIF socket also that works the same way, and you can just have pins on this, which I also got special pins that are basically dip chip pins that you can solder in here. Anyway, so the big differences here are to the full size is that we don't have the FTDI chip, meaning the USB core is in the FPGA. We have a bootloader that Sylvain designed that is loaded on here. And we have not only the flash for the configuration of the FPGA, but also an SRAM chip, PSRAM chip. So it is like SPI interface random access memory. To get more space, as well as a pre-mounted RGB LED, which is in here. Also, we are using the USB-C connector that a lot of people asked for. Otherwise, it is pretty much the same pins. We don't, of course, have the PMOD connections here, so you would need a breakout board. This is something I probably will want to do. But yeah, so last stream we assembled this, and in the meantime, I thought I will build something to be able to program this. And so I made this thing, which is, maybe I will do this instead. There we go. It will be easier to hold. So this, come on. Yeah, there we go. So this is a Pogo Pin adapter for the interface on the back, and it locates against the outer hole. So you have the outer holes here, and this will locate the Pogo Pin connector on the SMD pads on here. So you just press this against these holes, and it is located, and it works actually surprisingly well. A bed of pogos, yeah. So yeah, it's basically a Pogo Pin connector that I made. It was pretty easy to do. I just took some perf board, and I used 2 pieces of perf board that I used the stick vise to align everything. So I took the stick vise, I aligned the Pogo pins. I created a standoff on the back. So I glued some plastic together to make a standoff from my table to keep the Pogo pins elevated enough so that the sleeves are exposed. And then if we look under the microscope, let's see. So yeah, is this, there we go. So yeah, this is just soldered on the top here to the sleeve. And then I did the same thing, turning it around on the back to the pads. So they're soldered here. I'm always you have to be careful with not getting the flux to flow into the pogo pins, because otherwise they will become sticky. I did have one sticky pogo, and I used some IPA to clean it, and then it released. And then after all that was done, I soldered these cables to convert my programming adapter, which is this guy. Maybe we will switch back here. So this is something I built a while ago. This is an FTDI, like single port FTDI chip. And it essentially is just a breakout. So it has a USB connector, and it has this edge connector here where you can connect all the different adapters to, which is my, like before Tigard, my solution. I think I still like that solution, but I probably should make that using the FT2232 chip, which has 2 ports but only use one. The reason would be to consolidate things together. Again, it's like, yeah, 2232 HQ. Yes, that's the part. Anyway, so the fact that I have so many things that use FTDI chips, it's like, this is why I want to find an alternative to it. And I'm not even looking for something that would be similar to the FX2 chip. The problem with FX2 is that it is actually very useful that the FTDI chip is such a black box. Basically, everything you do is on the computer in software. There's no firmware to be loaded, nothing. It's just you connect it, and it's just a device with a fixed protocol that you can do a bunch of things with. I think this is actually a big strength of that design. The FX2 is very powerful in its own right, having the chip inside, but I think, or the core, the 8065 or whatever, it has its advantages, but for flexibility purposes. But I think for usability as a throwaway, really quick tool, I think that might be a disadvantage, actually. You want something that everything is on the computer side, on the software, and everything else is fixed, so that you can just quickly bring it up, and you don't have to understand microcontroller programming or optimizing for a microcontroller, squeezing stuff in and writing firmware, or even finding the right firmware to load and stuff like that. I think this is, having a black box is really nice. So yeah, that's that. I'm keep thinking about what actually the advantages are, why the FTDI chip is so incredibly popular, and this is basically on that list of reasons. And it would be nice to have an alternative that has similar set of functionality. There are alternatives if you just need UART and you need slower speed SPI. There are some chips, but and the ones that have SPI support, for example, are not very fast. You cannot saturate the bus with them. So yeah, anyway, so that's discussion about FTDI. So I took the programmer for the older version of the iCEBreaker bitsy. So this is the bitsy. It had the programming pins like in an L shape here. And I had this programmer that was plugging in there, and I just took the pins and adapted them with different colors. to make it nice and pretty. And that is the programmer to get the bootloader on. So you don't need it if you get it already pre-programmed. So let's see. So I have two of them. One of them is programmed, the other one is not. Let's see. This one is not programmed, so there's no bootloader on it. So this is something we will do in a minute and put the bootloader on. Bop it, heyo. Yeah, so that's a blank one. I didn't even touch it. Hopefully it works. And then we have this guy, which is already has this is a design loaded on here. Oh yeah, this when you press the button, the green LED goes on. And if you hold the button while you plug it in, it boots into, what? Come on, you boot into the bootloader. There you go. So that is the bootloader active. Yeah. While I was playing with this, I have one suggestion we could do. Yeah, it's very pretty. It's the fading. I like that Sylvain added the fading effect to the RGB LED. So Sylvain, I have a suggestion. We should probably indicate when the DFU is loading data onto here and show it on one of the LEDs that it is loading blocks on there. I think that might be a nice visual indication which device is actually being programmed. So yeah, that was a thought I had. Anyways, so let's see. Yeah, so Protobits, welcome. Yeah, so I can show you where it is. That was LCSC. Oh, awesome. So just push Esden-Temp. That is so funny. Esden-Temp is, because I'm Piotr Esden-Tempski, it's like having a branch called Esden-Temp somehow makes me really chuckle. Without the E, it still sounds very close to my full name. Anyways. So if you make the bootloader board bitsy V1 pre-clean one, it should build all in one step. Oh, cool. So that was, the bootloader was not building in one step. But we will get to that in a minute. I will show you. Yeah, I think it is interesting to see how these tools come together. Did you manage to find the low density USB-C connector? Yes. So it depends on the level of low density. So the one that I'm using here on the bitsy and on TiGuard and eventually on Glasgow is also from LCSC, and this is this guy here. It's even in my suggestion list, right? I thought that was it. Come on. C31M12? I thought it was it. Oh yeah, this is there. So this is the USB C connector. So low density as in only supporting USB 2.0. There are even lower density parts which are just for power delivery. So these are, they have even coarser pads, but only have the CC1, CC2 or CC0, whatever, for the negotiation of power delivery, and power delivery just the power pins, and they are nice and chunky and big. So if you want to just do a charger or some power supply or whatever, these are nice. These are just USB 2.0, and yes, they are easier to use than the full 3.1 capable parts. So yeah, the important thing is though, the USB-C connectors, there are two vendors on LCSC that make these. The only difference is how long the tabs of the shield are. And there is also very similar looking part, same footprint on DigiKey, but the pinout of the data lines is different. So be very, very careful. They are not a drop-in replacement. And it's a different vendor, and they, instead of having D plus, D minus, D plus, D minus, they have like D plus, D minus, D minus, D plus. So be careful with this. Always check. Yeah. Yeah, JKIV, that's the correct emoji for that. Yeah, but this is a nice part so far. Oh, important thing that I found out doing the TiGuard boards. It is possible to do paste in hole for the shield. So I opened up the aperture on the stencil to basically allow the paste to go in the holes of the shield. So let me see, like on the side here, the shield has like two pads here and two pads here that go through the board and solder in. So on the bitsys, I soldered them by hand. With just solder, and you can actually open the aperture and let the solder paste squeeze in when you squeegee it onto this. If you have a 1.6 millimeter thick board, it is possible to do without it squeezing all the way through to the surface that it is sitting on. So that's good. I just had little bit stuff touching there, like very small amounts of solder paste. But reflow, it is not in really enough solder to be 100% comfortable, but it is definitely tacking it in place and making it solid. I think for next try, I will expand the area that the solder paste can go on so that there is more supply of solder for the holes. Of course, if you are limited with space, like here on the bitsy, you can only do the pasting hole and say it's like, well, it's not very much of the solder, but it has to be enough. So yeah, so that's the story there. So what next? Yeah, the RGB LED. Let me think. Let's go just on someone. My brain. Optocopters, LEDs there. LEDs, light emitting diodes, and then there is RGB, and it is red, green, blue, RGB, apply. And I think, is that it? Yeah, there you go. And this is the first hit here. It's essentially 2020, so it's 2 by 2 millimeter part. So it is this guy. So I hope that, yeah, it's the Foshan Nation Star Optoelectronics. So yeah, I hope that answers your question regarding the RGB LED. So this is something we will be doing on the full-size iCEBreaker. My plan is to make some hardware changes and add the PSRAM chip, even if there's a jumper that is not connected by default. So I was thinking, the problem with I have a lot of examples that use the red and green LEDs on the iCEBreaker. Optical encoder. What's the question about the optical encoder? So PSRAM to add it on there, and the chip select is reusing one of the LEDs, one of the user LEDs. So I probably will leave that jumper not connected, and basically just just leave that disconnected until you want to use it for a design. Then you can just solder over and make an electrical connection. For a driver or electrical drivers, I'm not exactly sure in which context you are talking about here. Jump out. So yeah, that actually should answer that. So next step would be to essentially good question. So do you think I could get away with VIA in pad by plugging the VIA with solder paste and keeping it with Captain and similar? So oh, that's a separate question. This is I see. So that's a very good question. So I used VIA in pad for not critical situations. Yeah, it's yeah. So I didn't. I did make designs that didn't have plugged VIA. So for example, all the QFN stuff, if you have QFN parts, they have VIA and they're not plugged. But what they have is they are covered by a solder stop on the back. So essentially, you want this to be nicely covered on the back. If I show you here. So yeah, it's barely even visible. So this is where the QFN is. Yeah. So yeah, these are the things when you start squeezing things in and start like breaking the good citizens rules, and you're like, well, I need to squeeze it in. And I feel dirty, but I will do it. So yeah, fair enough. So there are things like you shorten pads on QFNs, for example, to be able to route out tighter one of the traces. There are things where you just leave out a pad that is not connected to route a signal under the chip, which is like hacks that you use. We are talking about all the design rule violations you would do to get your design just done with the constraints that you have. And yeah, you start breaking rules eventually. Such a dirty move. Yeah, I agree. It's a very dirty move, but very effective. Yes. All right. So yeah, this is all good stuff. Okay, so we wanted to essentially program the bootloader onto the. Let me switch over to the desktop here. So the bootloader is part of the iCE40 playground Git that is Sylvain's repository. So just for reference, this is where the bootloader lives in, and it consists out of two parts. It's the boot stub and the Rgb USB. So Sylvain's design essentially has a first slot in the flash is occupied by the boot stub, and it is pretty much only checking for a button press and either starting the user design, like using warm boot functionality of the FPGA, or it starts the Rgb USB, which implements the DFU bootloader. So there are essentially, when you have a program yourself, or you have a configuration for the FPGA yourself on the FPGA, you end up with three designs in the flash. The first one is the boot stub, the second one is the Rgb USB, and the third one is your own design. Roboscotia, thank you for your follow. Welcome to the stream. Yeah, so Sylvain said he made some changes. So what I did before was just go into projects bootstrap. I built bootstrap. I built with the correct parameters the iCEBreaker, the Rgb USB with the DFU bootloader, firmware loaded, and then combined it with the multi-boot Python script. This is the thing that I forgot. So my mistake was I didn't do the bootloader in a while. Jiggly Girls, welcome. Oh wow, awesome, congratulations. You got the position at Digiland Romania. That's awesome. Yeah, I hope you have fun there. Cord, thank you for the follow. Welcome to the stream. Yeah, so yeah, I hope you have fun there. Big congratulations. This is huge. Yeah, let me know how that goes, and if you have fun, and if you can share with us what you will work on eventually. I like the secret stuff that people are working on, especially, right? So yeah, so that was oh right. So I forgot this. So I loaded the bootstrap and then loaded the RISC-V USB in the same slot on the flash. So essentially, it was starting into the RISC-V USB, but it was not doing the right thing. And I was like, why is it not loading my design in there? So the RISC-V USB was doing the DFU loading, but then it was not starting into the payload. So anyway, so I just forgot that how to do it right. So Sylvain was so nice to make a new branch for us that should do it in one big step. So oh yeah, nice. It's always cool to see where people are from. It's like having two people from Romania. That's awesome already. I think there's someone from Germany. We have people from Belgium. We have I think also people from the US here. I'm at least currently located in the US. So yeah. So that's the branch, and switch to this from origin. That should do it. Let's look at this. So Smurge is usually nice to review the changes here. So, oh wow, there's a bunch of changes in here. So RISC-V USB board defines. Wow, thank you. This was a bunch of work in here. Rejigging this stuff. Import DFU firmware. That's awesome. Narcoid, thank you for the follow. Welcome to the stream. More targets and stub. So I guess you are saying I should do it in the boot stub, correct? We should probably add it to the README what the correct incantation is. But yeah, I think you posted it here, so I can just copy it from here. So board bitsy. So basically, make board bitsy v1 and then pre-clean 1. So basically, it will clean up that stuff. This should fail because I don't have nextpr loaded. So just also important side note, I am using since not so long, but I tested it a little bit. I'm now using the Open Toolforge binaries. So this is a project that Edward Borden is spearheading, and it is essentially a nightly build system. Open ToolForge, and there's the FPGA toolchain repository, and Open ToolForge runs nightly builds of all the FPGA tools, and you can find them here. It's like, yes, GitHub changed the user interface. I got very angry that I couldn't find it. But yeah, so essentially you can download a zip file for Windows, macOS, and Linux, and you just have to unpack it. So all I needed to do is download this, unpack it in my home directory, and then I can just export it into my path like this, and this should build at least that part. Command not found. Really? What did I do? Next PNR. Yeah, it is here. Weird. Okay, so there's some discussion here. Oh, it's rebased. Okay, yeah, all right, got it. Multi is lattice one with the GUI, so I'm partially curious how to done with. Well, yes, yeah. Yeah, it's probably not the same, but I will get there. It's like the interesting thing usually a lot of tutorials and a lot of people showing off what they do doesn't show the error messages when things go wrong, and these are like typical error messages you would get when the toolchain is not loaded. I've seen so many people just come into the channel and basically just pasting this kind of a message, and it's like, I have no idea what's going wrong, and it's like, well, comment not found, so probably it's not in your path, but I exported the path. It's like, yeah, are you sure? So there are these kind of things. Just reading error messages is very important. Just read everything. If you're still not clear, read it again, like all the words, even if it takes a little bit. So yeah, anyways, so it's just being old and grumpy, I guess, but it's important to read errors. Yeah, probably I have the wrong path. FPGA tools bin. Yeah, no, it should be. Yeah. Toolchain, not tools. Yeah. There we go. There's an example. Yeah, there you go. Thank you. Thank you, VT Ashton. Yeah, that's the kind of problems you get. And then now it will complain that it can't find the because the RISC-V stuff is already precompiled, I guess. So if I clean this up, Kandros, welcome to the stream. Thank you for the follow. So let me just clean this. Make clean. Oh, the target. What should be the target then? I'm sorry. So it's not the all target then. Make the bootloader. So, oh, bootloader is the, I see, that's the target. So you created the, there we go. All right. So I still want to clean things up because I want to see the error for the firmware. Unless it compiled the firmware and I just didn't, I already have it. No, it's not there. Let's go RISC-V, USB, make clean, and then firmware make clean. So I want to make sure I do it fully, because it should fail with the toolchain not being there. Yeah, there we go. Now it's correct. So I have to export the Rgb toolchain. There. FPGA tools, toolchain, Rgb toolchain. There we go. So I can also have here a tilde. And now I need, this is Rgb64 unknown elf. So cross, yeah, I guess the pre-clean didn't delete the firmware for some reason. I don't know. Oh, okay, that's fine. I know this kind of like the clean target sometimes is sometimes it turns out just the stupid clean target is the hardest part. I've had so many issues with that in the past. It's like, oh, because you don't notice it until you explicitly try and look for it, especially when you build it yourself. And it's like, yeah, anyways. And then you are surprised why your changes are not, if also the dependency system, when you have some files not in your prerequisites, it can become quite annoying. Okie dokie, so it seems to be synthesizing nicely. Yeah, I think it did already, because it's already building the Rgb core that requires the bootloader, like the embedded bootloader firmware. So yeah, even the Rgb core is like consists of several parts. So the Rgb has in BRAM a little bit of boot code, which is Rgb code, and then in Flash, after the design, the FPGA design that contains a little bit of code, and the Rgb softcore and the USB stuff. Behind that, in Flash, is more Rgb code that can be executed from Flash. So it is it's quite a Rube Goldberg machine at the end, if you think about it. But it all makes sense because you don't have only so much VRAM inside the FPGA, so you don't want to waste it for code, or you don't even have space for it maybe. So you want to put it in Flash instead. So it all makes sense. All right, so it built it. So what is the resulting binary? I'm trying to think. Multi-boot, iCEBreaker playground, bootstop, build temp bootloader bin. Okay. Yes. Also, you can't initialize SPRAM. You can't initialize SPRAM. What? I don't understand what that... So you are using the external SPRAM already for this? I didn't even realize that you are using the SPRAM chip in here. Oh, the internal single port RAM. Okay, so in the UP5K, the internal single port RAM cannot be initialized from the bitstream. There you go. Okay, now I got it. Okay, cool. So you need to load it from somewhere. So you load it from Flash in this case or something if you wanted to do that. Okay, cool. I didn't make that connection. Okay, so now let's wire things up. Desktop. Let's focus. So I will plug this into this USB hub. So that's the programmer plugged in. And now I need the USB-C. Is that the empty one? No, that's the programmed one. So let's take the empty one. So that's empty. So I will turn it around, rotate. Yeah, anyways, desktop. So just iceproc build temp and then bootloader bin, and all I will need to do is press enter. You should see it here. Let me just make it bigger here for you. So I need the 4 pins on one side. So this is not foolproof regarding orientation, but can I get it lower here? Maybe like this. Like this. Yeah, so I just press it on and then enter. Let's see. Can't find. Oh. Wait. Wait, what? Huh. Is it broken? Is it broken? Oh yeah. Do I have issues with this USB hub again? Oh, come on. Don't fail me now. That is ridiculous. Did you try turning it off and on again? Yeah. So let me try this on the other USB port here. Behind. Need to plug it into the back of my laptop because that's a direct port. Device number 3. There we go. There it works. Yeah, this USB hub has issues, so I need to. I really need to like remove it out of the equation here soon. Anyway, so let's. Let's do this again. 3, 3, 3, 3. And enter. There we go. That looks much better. It takes a while. Yeah, I really need a 3D printer by now. So making handles for this kind of stuff would be really nice, having a 3D printer. Or making a jig that can hold this down in a 3D printer. That would be all really nice to design. So I have plenty of stuff that I yeah, so this is not Amazon Basic. This is pluggable, and I read good reviews of them. So if you know of it's like, I don't care how much they cost really. The important thing is that they are robust and good. So let's see if this powers up. Huh. Okay, so this didn't work. Is the complete hub dead? No, it's not. So this didn't work. It's possible. Doesn't mean it's... So let's see. I have the image I made yesterday, so let's try to program that one. The bitsy bootloader image bin. I think that I made that yesterday. Let's see if that works. For there. It's fine. It's like, this is thank you so much for putting this together in the first place. I'm sure we can figure out what what the minor issue is. It's like in general it was working because I got it to work on the other bitsy. Also the hardware might be broken, you never know, so let's see. It's definitely writing and reading. Yeah, it seems something else is off here. What could it be? So let's look at this. Oh, now I don't have a mouse. Great. Wow, awesome. Can I get some kind of a mouse, please? Oh, God. It's not a Bluetooth mouse, it requires this stupid dongle. All right, there we go. I have a mouse now. Let's make this smaller again. Go to the microscope view. Let's see anything I can see with their eye. What could be wrong? Before I start trying to debug this thing. Yeah, I'm not sure I actually do want to debug this here on stream. Because I wanted to get to some other stuff too. Yeah, I still have some other binaries in other places too. So it might all be related to something. Anyways, I think we will just look into this later. Anchor 7 port powered one is what I moved to and have not had issue with a bunch of FTDI. Okay, cool. Well, that's good news. So yeah, I had good experiences with Anchor so far. I have a few of the Anchor devices and they have been very solid. So that is nice. I'm curious what that is though. It's like what could it be? Signal, it could be like one of the chips the wrong way around. Like no, it's not that. I got that correct. The flash seems to be programmed. For some reason it is not loading the configuration because you would at least get a blip on the blue LED. So yeah, I probably have to check voltages now. So let's see really quick before we move on. Well, voltages should be fine because I was able to program it, right? So ground and God. So this should be 3.3 volts. So this is 5 volts, correct. This is ground. This is 3.3 volts. This looks correct too. Yeah, weird. Should have like a blinky example to load on this too. And see if just the most basic thing loads. Yeah, I don't know. Okay, so yeah, I will have to do some debugging, I guess, later on. At least this one is working. I might try a different binary at some point. I somehow doubt that this is actually Sylvain's issue here. Oh, wait, yes, you're correct. Hold the button. Ha! Yep. That was it. It still doesn't fade for some reason. It's probably because it's not enumerating. Yeah, derp. Okay, so it is working. This doesn't work, but if you hold it, it does work. The RISC-V core doesn't enumerate. So does it not enumerate? Let's see. Yeah, so this is the complete hub is being a crapper. It's not loading the risky firmware. Okay, that's possible. So let's see. I will still check if it is a USB hub issue or not. No, it's not. Okay, so the firmware is not being loaded. Word, thank you for the follow. Welcome to the stream. Yeah, so it's not a hub related issue. It is a firmware loading issue. So let's see. Any thoughts what could cause the firmware loading issues? Should I load it by hand? I could load the firmware by hand. $286 Tech, welcome, hello. Retry the new firmware. Yes, that's a good idea. I will do that. And iCEBreaker. Hold it right. I wish, man, so much debris in here. I only see it in the camera. Sorry about that. It's just dusty. Okay, enter. Cannot find. Did I unplug it? Yes, I did. Follow cables, follow cables. Oh. Ay, ay, ay. Dohan96, welcome to the stream. Thank you for the follow. All right, so let's do this again. So let's mouse. Programming. This is another, I think I would like to add a progress bar on the programming for iCEBreaker. It would be a nice feature. Also on the reading. There we go. Okay, so let's see. Yep, perfect. So it's working. Oh, so you did rewire the RGB LED. It's like, so the pin out here is different than on the other one. I'm not sure which one is the correct one. Green and red fading, or the blue and green fading. So yeah. Yeah, I like having visual indication of things working or not working. So I'm always a fan of, like, when something happens, blink. If something doesn't happen, don't. If or well, here it is like active, which is fine. Yeah, I know. Which colors are the correct ones is a very, very mysterious thing by now, because with the RGB LEDs, we keep wiring them up, all the different combinations. So, anyway, so progress bars. Yeah, I like progress bars here. What I also want to see is the DFU load here to have some blinky animation, something to show that the device is, that this is the device that is receiving the new firmware. All right, so there is some more stuff to send pull requests for. Yes, so much fun. Okay, so next thing is I wanted to show you Sublime should open. This is Anaconda is being a problem here, whatever. All right, so just shut up. All right, so I started working on porting the examples, the iCEBreaker examples, to the bitsy's, which is a very interesting problem. So the examples were just fixed for the iCEBreaker, and as they are just examples, you want to keep them simple and you don't want to make them too complicated. So blink count shift is basically the most basic example in the list. And for the iCEBreaker, this is how it looks. It essentially has the LEDs and the buttons and the PMOD connectors connected. And what it does, it has a counter. And this counter makes this like pseudo-random blinking pattern on the 5 LEDs on the head of the iCEBreaker. And when you press the buttons, it sums them up and indicates the sum on the LED. So it's like you press one button, it's one LED, then two would be other LED, then both. So in binary, it indicates the sum of the buttons until it overflows with all 4 buttons pressed. But yeah, and then here we just shift a bit through all the pins. So what I did in general for all the jigging of the system, which I'm not 100% happy with, is to create a special makefile include that requires you to provide which board you are trying to build for. So again, take it with, I know this is not great. I will explain what I will change in the future. Yeah, so essentially you have this board file, and then if it is not the clean target, so this is something I didn't know, that you can check what the command line target is, so you can check that it is the clean target. So if it is not clean, then it will require you to either provide iCEBreaker, bitsy 0 or bitsy 1, and then otherwise throw an error when you try to build it. So it looks like this. Blink count shift. So if I just run make here, it will complain, please specify board option. Options are iCEBreaker, bitsy 0, bitsy 1. So because we have 2 versions that have different pinout. The previous version had a different pinout on the pins. So the PCF file will be different. And the PCF files, we have now 3 PCF files. The original iCEBreaker PCF file, which is this one. So pin constraint file, meaning mapping names to the FPGA package pins. Then PCF file for 0 and PCF file for 1. And we care about the bitsy 1 at the moment. And we have those pins here that we have assigned. And if I do make and then board, iCEBreaker would be just iCEBreaker. I should clean. So this would be just the iCEBreaker. And I think what I should do is make those targets like sensitive. Anyways, there are more ideas what I can do. So I can make like create files based on the target to make sure that it is being rebuilt if you change the board target. So Makefile has a lot of weird hacks you can do to make things behave correctly. Because when I build bitsy 1 now, it will do nothing, and it should build the bitstream again. Cicolate, right? Wait a second. Cicolate? Cicolate. Welcome to the stream. Thank you for the follow. So yeah, there are ways of making flag files for this to force the rebuild. Yeah, so I think usually it's essentially when you have the board, you depend on a certain file and others are being deleted. You rebuild if this variable changes, then the requirement which file should exist changes, and when it doesn't exist, it deletes the other files and creates the new one with that correct name. I think that's the way of doing it. And I'm not sure there's any other good solution for it. Probably there is, but anyway, so this will build the bitsy one, and something I learned. Yeah, we could put the binaries in subdirectories too and have them separate. Yeah, that might be an option. So that it then completely rebuilds. Yeah, that's also a solution, to have separate target folders depending on the board file. But in general, I'm not very happy with the variable solution here. I think all targets should be disabled and only give you a list of options and tell you the target you want is either bitsy or something, and use it as a prefix for prog. So have a bitsy1-prog or bitsy0-prog. How it then manages to indicate and make sure that the correct thing is built, that is still an issue. But the user interface, I don't feel like having board variable is that of an intuitive solution. It works. So that is a second option, to have targets. The third option is to have a menu config target, like in the Linux kernel. I like that solution a lot, because then it gives you more options with a TUI, so text UI, and you can actually configure the target much more comprehensively. I remember using that with Claire Wolf's Rock Linux. We did lift the special binary that the Linux kernel is using to make the menus, and wrote everything else in shell script. So we can shell script all of that and only need this tiny binary to do the TUI stuff. I wanted to do that for several projects already, and I really want to dive into this. So Blackmagic Probe would really benefit from that, for example. And also this kind of designs would benefit from it, where you can select. And essentially what happens is, if you just run make, it will say, it's like, I don't have a valid configuration. Please configure me with the menu config target. Then you run menu config, you get the dialog, set up everything, save, run make again, and you have it. You can also provide a pre-configured file, so like the old config, right? So make old config would then suck in an existing pre-configured file. So there's a lot of functionality you could do to make this build system very flexible and very fun to use. So I really want to work on that, and probably I will go to Rock Linux and lift the menu config binary from there. It's a very small C program. This is the question though. How hard would it be to make it run on Windows? And it's like, such a pain that so many people are using Windows and try to build stuff, the toolchain stuff on Windows. If it was just Linux and macOS, it is much less of an issue, because you already have to have the compiler to do anything useful on macOS, and you definitely, and very likely you have them on Linux. On Windows, it's like, oh, do I have to have Visual Studio installed? Do I use this compiler to build stuff? And it's like, it's such a different universe what Windows does, that it makes everything like 10 times harder than supporting macOS and Linux. So yeah. My another rant about how Windows is terrible, but yeah, Windows is getting better. To be fair, it's like the WSL is helpful, but it's still, things tend to be sometimes very complicated. But yeah, anyways, I'm sure we will figure it out. I will probably build it for Linux first and go make it work for me. It's like, works for me, done, ship it. That's always a good idea, isn't it? Yeah. So, all right. Where was I? So, the build target, we have the PCF files for bitsy, and what I did is the make file has this option to add a top V suffix, so we can have the board have a suffix. So instead, there are two ways of modifying the Verilog to match the particular board. One way to do this is how Sylvain did it with Verilog like if-def statements. And I started doing that. So basically you do this backtick if def. I thought it was if def. And then it was board underscore bitsy 1. And then switch it around depending on which board you have. And then you can switch on code on and off. But the amount of board-specific stuff in this example versus another example for the bitsy 1 is so huge that for this example, it doesn't make sense to reuse code. It makes more sense to actually have several Verilog files for each board 1. So that's what I did here. It works for me is the best release policy. Yep. Yeah, it's like, it is a thing. So yeah, I essentially created Verilog files, and this is why in the make file I have this suffix which I can have per example. So let's just do this. And one more thing that is important, the board MK also sets which programmer to use, if it is using DFU or it is using iCEBreaker. So anyways, after that, if I do, this will, it should actually work. This is in the bootloader, so it is blinking and saying it is the bootloader is running. So I should be able to do proc, and this should load the bitsy binary on there. But no, because I need to do it as sudo. There we go. And loading. Bam! So let's see what this example actually does. It's very simple. It is just counting through all the pins. So important thing is the P13 is also the red LED. So the red LED is also available on P13 on one of these pins. So it means I decided to do with the go with the P13s to have all of them here instead of with red LED. And the LED green is connected to the button. We are not testing the RGB LEDs, which we should do at some point. So the example should do that, but the button also works. So that's very cool. And so what we could do, another thing that would be very interesting to do, especially for the iCEBreaker, is to have a way to jump into the bootloader out of the payload application without a DFU stub. So DFU stub would be having a USB core just there so that it enumerates, and then DFU util can reboot this device into the bootloader. This is something you do on microcontrollers if you want to have DFU. But currently, what we have to do is unplug this, hold the button, plug it in again, and then it will go into the bootloader. So that is what it is. The alternative would be to have a counter that you hold the button for a certain period of time, and then it basically resets and goes into the bootloader. So that is much less logic to do, and you just have to trigger the warm boot with the correct parameters. So that will definitely take much less space on the FPGA than having a full USB core. So yeah, I need a very short break, and then we will continue with more things and hopefully get to nMigen too at some point. So don't go away. It hopefully will be interesting. So see you in a second. Okie dokie, I'm back. Sorry about that. Let me check what's going on here. Ah, yeah, there we go. All right. So, yeah, so that's basically the situation here, and that's the first example I wrote. I think we can consider porting something depending on how much time we have, but I would like to show you nMigen first, and I would like to get that to work. So we have an example in the in Verilog, and so that is a good start already. We definitely don't have anything really in nMigen at the moment, so let's see. If you want to look into what I'm doing here in Verilog, it is in GitHub, Esden, iCEBreaker examples. So there is a branch called bitsy. I have like 2 branches here. I have to figure out why I have 2 branches here and merge them together or something. I'm sure I was working on some other stuff earlier, and yeah. So anyways, this is this should be the correct one. Yep. So if you are interested and if you have one of those boards. So now that I know that most of the hardware works, I still need to test probably the PSRAM chip to make sure that works. And if that also works, then I can probably build the remaining boards and send them out to the people that I wanted to send it to. It's like definitely send one to Kate Temkin to add to the Luna USB project and make support there. I send it to what's his name to add CircuitPython support for it, hopefully, and yeah, things like that. So yeah, and multiple things that I want to do. But for now, I wanted to look into nMigen. What is it? Where are we here? nMigen examples. Perfect. So So iCEBreaker platform is, so what I did is I ported, or not I did, what I need to do is port there we go. So this is the nMigen boards Git repository. So here on the top, you might see this in small font. And this contains the iCEBreaker py file. And we don't have the iCEBitsy, so iCEBreaker-_bitsy. So I think that's how it should be called. And iCEBreaker bitsy, I guess we have to abbreviate it here to make it easier, because this becomes really long otherwise. So just iCEBitsy. Yeah, we can change that later, but I need to essentially adjust this. This is all correct, and but yeah, let me go to here. No, that's in nMigen. nMigen boards, and nMigen boards is here, and then copy iCEBreaker to let's do bitsy1.py because we don't have the 0. And we should probably go in a separate branch, but that's for later when we make commits, I guess. So I did install nMigen in the so source nMigen activate. So that's the venv. I did install this with pip. And then install editable dot. So basically you install the package with editable. Oh, important thing in this context. There's more documentation that got released between last stream and this stream for nMigen, which is very exciting. So White Quark released this. So nMigen info, nMigen latest is, I think it is also linked from the repository itself. nMigen, no, not sock. We will get to you eventually too, don't worry, but not sock at the moment. Introduction section of the documentation and installation for the document. So there are the links are in here, so that's good. And the most important part is the installation section. So if we go in here, we have multiple options, macOS, Debian, and other Linux with these tabs to select which installation we want. And one of them is also to do the editable one. And did they change that in between? Because the built-in Yosys, it was listed that you can just omit the built-in Yosys if you want to use the binary by itself. Weird. I did see that. Immediately affect the code that uses nMigen to update the snapshot run. So fast forward only. Yeah, so anyways, you can basically just omit this part if you have a locally installed Yosys and next PNR and whatnot, so all the tools, instead of using the built-in ones, which are basically WebAssembly compiled Yosys binaries. So I didn't try it yet, the built-in stuff. I was too busy doing other stuff. So this might be an interesting thing where you do save a bunch of effort by not having to install the tools. But with the Open ToolForge binaries, it's pretty easy to install the binaries itself. So yeah. Anyways, so I made the copy here. So let's see. And so iCEBreaker bitsy1 platform. So let's call it that. I don't know what that does. Some registration, weird. I don't know what that variable does in Python, but yeah. I guess we need to adjust this. So let's rename this stuff. Break off pmod. We don't have the pmod anymore, so we can completely delete that one. Randon, Rdan33RL, Daniel, R Daniel. Thank you for the follow. Welcome to the stream. Need to decode lead speak. Yes, so what do we need? The clock is correct. This stays the same. LED resources, we should probably adjust those because these are different pins. And for that, we should open KiCad. Just open KiCad, and then iCEBreaker bitsy is the 1.0 version, yes. And then we can go either here. So we have, for certain things we can look up here, and others we can look in the design file. We have this pinout information in here. LEDR is 25 and LEDG is 6. Again, LEDR 25, 25, 25, and then it was 6, correct? 6, 6, 6. This is what I like about nMigen, is the fact that after you do this assignments in here, you can essentially move on and have reuse the stuff. You don't have to look up the FPGA package. Oh, it determines what happens when you do from module import star. Interesting. So the wildcard import, which it's interesting though, in the Python linting. So if the Python lint runs, it's like somehow it is not running now because for some reason Anaconda decided to break. But it does complain about wildcard imports. Like wildcard imports are not making the linter happy. But yeah, the linter is complaining about a lot of stuff that you very often disable. so I don't know how valid that complaint is. Anyways, so that's good to know. Thank you. I'm learning about Python. That's good. Then button resources. This is the one button that we have. So button resources is there, button 2. And then UART resource. So we don't really have UART pre-wired by default anymore. If we go with Teensy, how that is the default pin out on Teensy is, this would be actually pin on here. It would be these two pins, pin 0 and 1. P1, 0 and P1 would be the correct pins. So 0, 1. For UART 1 on the Teensy, there are others like 2 and 3 UARTs. So for my examples, when I do UART output, this is the 2 pins that I will be using to essentially keep some kind of a guidance from the Teensy platform. Yeah, so I think we have to delete this here because we don't really have that. SPI flash resource. So we have chip select. This should be the same. The write, protect, and hold are different. Write protect is 18. Waiting for the bitty board. Thank you, Bay Yusuf. It's like I guess you. I'm curious which one you refer. It's like are you talking about the bitsy or something else? Hold. So hold should be here, and the pin is 19. Okay, so that's cool. And then we have a connector. How do we call it? How do we call the pins all around? All around this thing. Should we have also all the pins somehow exposed as pins here? Huh. I like how this is also like taking care of if this signal is inverted or not. We should add the RGB LEDs at some point too in here. So they are not here. So the break of PMOD, we don't have that. So we can get rid of this. BUX77, thank you for the follow. Welcome to the stream. So how do I do this? Just con or pins? I don't know. I don't know how to call this. Because you would use this connector to add a resource to. So because if you look resources, see, it is basically pulling in, when you have this break of PMOD, you say which LED resources you have, which pins they are, and then you have which connector it is connected to. And then you can select PMOD2 to be the connection that you are connecting to. So the connect PMOD2 would be here. And you basically address which pin is which just by ordering them. And then you can, this is how you skip pins. So essentially in our case, because we have P0, does it start with 1 instead of a 0 in the connectors? I think it does. Oh, great. Yeah, so it won't start with P0. Huh. Oh well, it is what it is. Okay, so let's remove this, and then we can go like this, and then do just pins. This is connector 0. Yeah, the pins in a connector start at 1. Yeah, well, it's like, is it? Yeah, it is confusing because we have two standards. We have index. So, oh yeah, index. It's like, if you have a PCB layout, you also usually see the pins starting with 1, not with 0 on a pin header. So it really depends. Are we talking about software here, where the indexes usually start at 0, or are we talking about hardware interfaces? So this is more on the hardware side. The index starts at 1, but yeah, I don't know what is the right thing to do here. It is definitely confusing for sure. All right, so let's just pull in the numbers here. So if I go to the PCF file, Yeah, it's all freaking confusing no matter what you do. There's no real standard. That's the problem. It's like there are some conventions, but that's pretty much it. Okay, so let's see if I can... No. What is the combination? Frick, 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 frick. There we go. And then shift, copy, all right. How do I don't remember how I combine them. In VI it is Control J, but there is also a thing to do that in Start at 3. Yes, yes, that's the solution. Confuse everyone even more. Yeah, so probably I should have 2 connectors here. What happened? Oh yeah. So I probably should keep the connector like the left and right side, or the bottom and the upper side separate. Top and bottom connectors. Yeah, but where is top and bottom? That's the question. Where's up and down here? I know where up and down is based on like my PCB design. That's in KiCad, right? Oh, is there a default on the dip? It gets parsed, yeah. Bottom left, oh. Okay, so I can do top and bottom. So let's pins bottom. Okay, how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13? How many are they? 24, so it is 12, correct? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's it here. Like this, something like that. And then connector top. Yeah, that's the question. So the advantage of having them in 2 separate yeah, let's just do it for now. It's like when I get annoyed that I don't have them in separate connectors, I will do that. Yeah, you are probably right. It's fine. Yeah, I don't know if I can. I think I can split them, right? In Python, I can have 2 strings just attached together. Yeah, so the aliases happen when you have a pair of... So yeah, maybe I can have multiple connectors with like just pins, all of them, then pins top, pins bot as another connector. I think they can overlap. So essentially you have them in multiple sets. Yeah, I'm pretty sure this is possible. And yeah, This is still a learning curve here for me. So anyway, so I need to Smoke Bath. Thank you for the follow. Welcome to this stream. That's a good nickname. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yay, I can count. Will this work? Can Python deal with this? I think it can. Do I need to like add like an addition or something sign here, or will it just merge them together? That's what I never remember. It's too many languages. Oh, triple tick. Like this. Will this just work like this, or should I have them the triple ticks on 2 lines? I'm not sure. Anyways, this should be able to parse. Yeah, pretty sure which one. The asynchronity of the communication bites us once again. It should be parsable this way, the way it is, but yeah. Anyways, so the important thing actually is not to doesn't care about line breaks. That should work. Yeah, I don't know if it cares or not. I doubt it does. Usually this stuff, the naive way of using it is how it works. The first one or the second one, yes. Yeah, thanks. That confuse even more. Not just a Python list. I don't know. It might be a carryover from. So on Monday, I didn't realize this was a regular thing, but it seems that nMigen contributors have like a developer meetup on Mondays on IRC. And so yesterday there was a meetup and they were like talking about a lot of stuff. And one of the things is like how the pins are being managed. WhiteQuark doesn't seem to be super happy with the way it works. So there will be probably some changes happening to it. Yeah, but it seems like it might be more verbose or something. I don't know. Yeah, so the important thing is that pins on the on different FPGA, they are not always just numbers. They are sometimes also number and letter combinations. So you need to have them as strings at least. So you could have a list of strings, but definitely you can't really make them symbols. It's not Lisp after all, where you could just make a list of symbols and then parse it directly. So yeah, in Lisp you could make it cleaner with just writing a list of all the pins that you want in there and be done with it. And then the DSL takes care of it. Oh man, I miss Lisp. All right, so environment, get iceprog, get dfu util, like this, and then few util. So the important things are here. We need to, with products, extract bin, format name. So the name of the, so self product's name. So you have the, this is what you pass as bitstream file name. And then subprocess check all iceprog, it should be dfu util. Right, and then we need to call this with some parameters. So there's a little bit more involved because in this second section here, I think we need to have the slot we want to flash it into. Where are we? We are here. Projects, iCEBreaker. Oh, yeah, I can just open it here really quick what the invocation is, because I don't want to have to remember. Main make, and there we go. DFU util. So address is 0, then D, and then R for reboot. So let's do this. So I know we probably want to expand this to be a little bit more flexible, but let's just get it to work for now. C9 file name and then -R. I hope this works this way. And then we have Blinky, break of pmod. We don't want the build Blinky. Where is Blinky from? That's the question. Resources. I'm really curious what that is from. Anyways, that doesn't really matter, but because we want to just try this. So I will just you probably have to split up the arguments in separate list entries. Oh, so I can't just combine them in one string. So I have to have it like this. Yeah, that's very possible. Test blink import. Oh yeah, test blinky. So there are tests here. There we go. So that's the blinky here. LED, get all resources LED. For resources in, resource output, button switch. Interesting. Okay, cool. Oh, you can. Anyways, we will try it in a second. So let me just finish this, and let's just try this. So we want build blinker do program true. So all we need to do here, I think, is copy this, and then import instead of wait. This, copy this, and then iCEBreaker bitsy1, and then iCEBreaker bitsy1. That should do it, right? Anyways. To raw exec. I see. Yeah, we can check that in a second. Nickloop TTV, thank you for the follow. Welcome to the stream. So yeah, cool. I think that does it. Let's try it. nMigen boards, iCEBreaker, nMigen examples, blink, and Python blink py. This will fail from nMigen. Oh, it's the wrong one. iCEBreaker bitsy1, like this. All right, so error command, yeah, the DFU signature. So this is the, so the interesting thing now is my UDEV rules do not expose the DFU device, or this device does not have permissions for me to access as a normal user. So this is something I probably should fix, because if I even do this, so the bootloader is even booted. Sorry, I want to bend this so that it is visible for you. And then we want to do this. Yep, and which way? Can we do this? Come on. There we go. This way. That should be better visible. You should see the blinky LEDs. Yeah, so if I do just run this, this will still fail, yes, because I don't have permissions. So now I have to figure out, sure, update my Z show. Okay, so etc UDEV rules D. I'm sure I have DFU somewhere. Paparazzi DFU devices, then HackerF DFU is also there, and I think FOMU, HackerF? Glasgow. Does Glasgow have similar things? PlugDev. So basically all I need to do is just expose the whole device with the correct ID vendor and ID product to PlugDev. Yeah, that should do it, I think. iCEBreaker rules. And then let's do LS-USB. And all we need to do is Linux Foundation Magewell. Where is it? OpenMoko. That's it, I'm pretty sure. The U-access stuff. Yeah, I think I saw that. I think we kept it is kept there in Glasgow because of backwards compatibility with older systems, because that's the example one. But yeah, so the tag plus U-access, yeah, that's the correct one. Yeah, and I didn't remember what the ID was. Let's copy this. Wait, so LS-USB device device, and then this verbose, right? Because let's check that. Yeah, this is that ICE40 USB device, Osmocom. So that's definitely this. This is Sylvan's bootloader saying hello. Vendor and product. Okay, cool. So this is vendor, and this is product. I think. Did I remember this correctly? My head is such mush today. It's really bad. Yes, vendor, product. Okay, so that should do it. So in theory, I could remove the PlugDev group thing and just use the tag plus U-access. But yeah, that would be it. Let's try it. Checkcoder, thank you for the follow. Welcome to the stream. So let me unplug this, hold the button. This should boot. Okay, and now let's run the Python script again. Yeah, there we go. Perfect. Good job. I didn't even have to reload the UDIF rules, which is nice. Perfect. It's blinking. It's blinking. That was quick. Getting nMigen running on this. At least the most basic thing ever. That's so cool. Whee! nMigen for everyone. So yeah, we are also already even getting to the end of the allocated time. But what I am now curious about is after I get these things to work and the examples to work on this. So next thing is definitely testing the PSRAM. I definitely need to send those as a pull request to add the boards as supported, make more of these boards, and send them out. Oops, sorry. Send them out to several people. I might, if we decide that this is very close to the final version of the hardware, I might actually put a few boards on the store for whoever wants them to have early access to them. And then the really difficult part will start, which is how to panelize these. So this is something I completely didn't think about when Jordi was designing this board. With the castellated holes, how do I make tabs for this to make it possible for to panelize these boards? So essentially I have to have like a tab. If you look at this, it's like a tab here and here next to the USB connector. Then I can have a tab here on the opposite side and maybe like a whisker tab like they have on the yeah, and I can't really have any tabs on the sides. It's really annoying. Yeah, I really don't know what to do here. And how do they do post-processing for the castellated holes? This is another question I don't have a good answer for. Yeah, I think what I will have to do is essentially send that to PCB manufacturer and ask them, it's like, hey, if I wanted to panelize this, how would we panelize this? So yeah, that will be interesting. Anyways, okay, so we have nMigen working, which is very nice. It was easier than we thought. So, oh, the other thing we wanted to test is if we can just combine this. I doubt this works. Yeah. You need to specify one of the, yes, so that fails miserably. So yeah, it is as you guys said. All right, so that works. That will fail too, but not at least execute correctly. Okay, so anyways, this is pretty much it for today. I will definitely look into this to send it upstream so that we have that and people can play with this. I had a few thoughts about the board in general. Let's switch this over again to a little bit brighter image. Come on. There we go. There we go. So, as I said, let me get a pointer here. So the tabs that I was talking about, it's like we can attach one here, have a tab here, we can have a tab here, we can have a tab here. I don't know how to attach anything to the side here. It's like there is some space here between the vias, between the holes, but it's still, I don't know how that would work. We might be able to have like a whisker one here, but then we need like some supporting rail, as usually the boards go in this way into the pick and place machine. and would be pushed on this way. So I seriously don't know what the right solution here is. And then you need plenty of space here for the castellation cutout, and so that they can post-process the castellations. The other thing that I am still like grinding my gears about is how the programming connector works. So if you think about the fact that this might be mounted in a socket like this, you have access to the USB-C connector to reprogram this, which is nice. But you don't really have access to the backside if you want to put like some like other firmware on it. And so having this is like, yeah, it works for certain cases. I am not 100% convinced that this is the right solution. To a certain degree, I would prefer to put like a fine pitch connector in this area to have a programming interface here. So these are the things that I'm thinking about regarding the design. Otherwise, I think the pinout will stay as is. Most of the things I think I'm fine with. The voltage regulators seem fine. The RGB LED seems to be fine. Everything else seems to be correct. But these are the only two things that I am not 100% convinced. So the thing that we need to test before we press go on this is, let me see here. There we go. So this is the Teensy audio board. I would like to test that. Oh, that's why. Right, is that this orientation? Is this going like this? Ground mic? No. Microphone is separate. Doesn't it go like this? I think it is mounted like this. So it is actually not using these, so that's fine. So we don't need these for the audio shield at least. Or do we? Oh yeah, the ground is connected here. That's the orientation. I don't remember. That's I would have to look it up. But it would be really good to figure out that this works and the SD card interface works and stuff like that. There's a bunch of different like design stuff that we need to test. The other thing that I was That's a very good point. Yeah, you could do that. Yeah, you definitely can do that. Right, good point. Very good point indeed. Let me get a thing. Where is it? There's the thing. I got something from Joe. Oh, you need the reset and see done. Yeah, that's the problem. Right. So yeah, that's not really working. Why is this so sealed so hard? Yeah, so it just doesn't work. But yeah, that would be a clip like this. One could, in theory, clip it on like this. There we go. But yeah, because we don't have this see done and reset. Yeah, right. You don't. Yeah, fair enough. So at least you would need this the C reset, so chip reset, for the FPGA to keep it in reset so it doesn't interfere with you programming it. But yeah. Otherwise, you would just need this to program the flash. That's a bummer. Series resistors? You mean on the I/O? series resistors for the FPGA? No, we are not adding them. It's like this. The routing on this is a nightmare already, like a major nightmare. I am not putting inline resistors on this I/O, so that's not happening. And I don't want to add stuff as a backside load anymore. Yeah, we thought about this hard and long, and I think it is. I think we are good. I don't want to do this. Oh, you mean for the FPGA? Like, oh, basically like to override the interface? Yeah, right. So that's a different story, if that's what you mean. That's, yeah, no. Especially if we want to make sure that our programming, that we can read out the flash at maximum speed, and it's like 100 plus megahertz is possible already, and I don't really want to impede that. That's a very good point from Sylvain there. I think it is the right thing to have a reset. So I think all we need for programming is data in, data out, clock, chip select of the flash, and the reset pin of the FPGA. C done is optional, and we need ground. So it is 1, 2, 3, 4, 5, 6 pins, including ground. Yeah, you need the reset pin for the FPGA at least. So what did I say? Data, clock, chip select, reset. So it's 5 plus ground, 6 pins. So 6 or 7 pins. And here we have space for 1, 2, 3, 4, 5, 6, 7 pins. If we do it the point half pitch connector on here, linear. So that would work, for example, if we replace this with a half pitch. But if we need this ground and this power for certain hats or shields, that's a bummer, because then we need to keep these holes, and I don't know where to put the connector otherwise. So yeah, this is something I'm not clear about, if we really need these pins for certain boards, or if we can forego them and put the programming header just here along the edge with just half pitch, just like we do have on the Blackmagic probe essentially. That would be preferable for me than having this backside connector that is fine for certain situations, but it's pretty constraining if you want to have access to everything from the top, especially when it is mounted in a board somewhere in a system and you want to go in there and reprogram the bit stream that is not bootloader enabled. Or you have this thing mounted so that it is like really deeply in a system and you only have access from top. You can't access the USB-C connector, for example, and you want to reprogram this. It would be nice to have a pin header that you can connect to from the top and just reprogram this thing. So yeah, so this is the programming interface is my major question mark at the moment. The second one is the tabs for panelization, but otherwise I think we are pretty much there. So yeah, I am looking forward to have some more people kick the tires on these boards. So after I find some way of testing the PSRAM, I will finish assembling the remaining 9 boards. So it's like I have 2 here. So 7 more boards to assemble, and then they will be available to ship out. Oh, I also have some of the previous batch. So if you are interested in the previous version, it's like the pinout is different, but otherwise it is very close design-wise. If you are interested in the previous boards, let me know. I probably can send them to you like at cost or something. So let me know in Discord. Just ping me in the iCEBreaker channel. Yeah. Wow, Ginny, thank you for the follow. Welcome to the stream. Yeah, so, right. So that is the story about this. One more thought. So I would like to work on a project involving the iCEBreaker bitsy. So we have those nice sockets, and what I thought would be really cool is to actually combine it with the Tiny Pico. So Tiny Pico is this board from Unexpected Maker, and this has a very similar form factor vibe. It's not Teensy compatible, I think, but this is this board, and it is an ESP32 wireless chip. So what I was thinking would be cool is to take these and then take an LED panel like this. Okay, let me zoom out a little bit, maybe, yeah. LED panel like this. There we go. So take the bitsy and take the Tiny Pico and take an RTC clock and a panel, and then we would have a wall clock with Wi-Fi interface that we could display stuff on if we wanted to. So to get the Twitch subscribers and stuff like that, we were talking about that to get like indications like this. This might be a really cool cool solution to use one of these and essentially have a board that plugs into the back. Oh, thank you for the host. Thank you so much, Wild Genie. I appreciate it. So yeah, it might like be a board that plugs in the back. Someone, oh, I'm so terrible with names. There are people that are working also on Power over Ethernet stuff with the iCEBreaker, like with the same FPGA as the iCEBreaker, also for LED panels, which also is an interesting solution. But I think this might be nice because then you just need power, and the Wi-Fi will be for the clock sync and for communications if you want to send stuff to maybe like a few framed animation that you want to store in Flash, or you want to have a marquee with a message that goes through, something like that. It might be very, very cool to do either with this 64 by 64 or 32 by 32. Gelek Binide, thank you so much for the host. Thank you for hosting. I appreciate it. All right, so yeah. Anyway, so this is thoughts for upcoming projects that we could work on. The other thing, because of the form factor, would be to build some retro computer, retro console inspired thing where you have several subsystems on separate chips. Yeah, I have a lot of ideas what one could build with the bitsy. I'm just not sure which one to tackle first and which one I will have time to tackle. Yeah, it's all, and also there's plenty of other projects to work on that I need to finalize. So I have more ideas and hopes to work on stuff than I have time, unfortunately, as pretty much everyone does. So yeah, these are the thoughts that I had. Nirere, thank you for the follow. Welcome to the stream. So yeah, let me know what you think. Let me know what you think about the possible projects we could work on. There's definitely a lot to do. Yeah, and then also, yeah, I need to get that feather adapter. So there is a Teensy to feather adapter to connect the Teensy to a feather hat. So there's like another full ecosystem we could plug into. Yeah, I have to see how that plugs into everything. Haha, pun intended, I guess. Yeah. I think that would be pretty much it for today. Unless you have any additional questions regarding the Pulsaker, thank you for the follow. Welcome to the stream. Yeah, I don't know. There's probably other stuff. Oh, right. So twang. So we have to talk about twang a little for a second too. So as you remember, we have this joystick and we have this LED strip, and we wanted to recreate the twang game where you have this one-dimensional dungeon crawler. I started on that early in the year. I wrote an emulator and a big chunk of the game in Python with the thoughts of using Circuit or MicroPython on the iCEBreaker. Then I rewrote that stuff in Rust to a big degree because I find Rust fascinating, and a good excuse to learn more Rust was to basically just rewrite that game in there. Anyway, so to do that, on the iCEBreaker, we need an SoC. So we need a soft core with a little bit of peripherals. I started doing that, and I did release Litex, which is the SoC creator, which can incorporate a RISC-V core and some peripherals. But it is relying on nMigen, and I want to use nMigen. So now I have to figure out which way to go regarding nMigen. And I think I need some input from people that might have more experience with this. I think what I have to do is create a new project that probably uses Minerva core, which would be also an nMigen RISC-V. I'm actually curious how efficient that core is. So lambda concept. Yes, Minerva, I think that's what it is. Yeah, so Minerva is a RISC-V core written in nMigen. So that would be doing everything in nMigen. So have the RISC-V core, then have the peripheral written for the LED panels and like buttons also in nMigen, and then use the nMigen SoC, which I by accident opened earlier. To combine it all. Oh, okay, interesting. So Lambda SoC has everything already. I'm not sure what the relationship is between Lambda SoC to the nMigen SoC. So that's something I don't know what the relationship is there. Okay, so it is more of the builds upon nMigen SoC. Interesting. Yeah, I will look into this. So there's also this, right? So Lambda SoC. There. So it is like a continuation expansion of the nMigen SoC, I guess. Yeah. Divine Alien, welcome to the stream. Thank you for the follow. Yeah, so that's good. I will try that and try to get that working. Term. So it seems to be very easy. Python example SRAM SoC. Then you select which platform you want, and then it builds the SoC for you. That's cool. Yeah, I will look into this. That seems like a good path. What I also need beyond this, and I don't know if it is supported yet, is being able to generate the header files or the SVD files for Rust API generation for the config and status register, the CSRs. For the CSR, so config and status registers of the resulting SoC. This should be auto-generated if possible. It's not a huge deal if I have to write it by hand for now, but it would be good to have that there. also the auto generation of documentation of the API or the hardware API or register definition of the core, which is part of LaTeX. That would be nice to have in here. So there's like a very nice, very nice. So I didn't read all of the meeting yesterday, so I missed probably that. But yes, that's cool. I'm looking forward to that. But I do think that all things barred, I don't know what my other to-dos are, but I think the main thing I want to do until the next stream next week, I'm not sure I will be streaming on this Thursday, so I doubt it, actually. So I think we will see each other on Tuesday next week. But until then, I think I will start digging into the SOC and nMigen stuff, like besides like pushing upstream the config files for the bitsy, assembling them, sending them to people, and whatever else is still to be done. But I really want to look into the core and get it. It seems that this should just work more or less out of the box if the correct config is there. Oh, wow. There's like already a tutorial using nMigen. That's cool. Learning FPGA with nMigen. That's a new thing. I have not seen this before. Wow, that's awesome. Oh, this ugly board. But yeah, otherwise, that's very cool. That's very nice. Oh, wow, that's a quite comprehensive tutorial in here. Oh, I will thank you for sharing that. That's very cool. Treffer 99. I assume that's how you want it pronounced, but welcome to the stream. Yeah, I know it isn't the... it is in this section of nMigen documentation? Okay. So, introduction, getting started. Is that probably linked from there, I assume? Yeah, I have to read this. I have not had time to read this yet because I was rushing to get at least some basic stuff running on the bitsy and fixing that, like trying to get the multi-target capability in the examples. Tutorials link there. Okay, cool. Yeah. Oh, tutorial there. There we go. Oh, Bob's I want to learn nMigen is in there. Very cool. Very nice. Yeah, thank you for sharing that. That's very cool. Yeah, so there's the documentation of nMigen is really coming together, and the tutorials are coming together. So I hope I can also share some of that process of getting stuff done. I do hope we can eventually do some building of stuff here on stream too, but I'm still so unstable in my own knowledge about the nMigen myself. So it is I do some basic stuff. We did the porting of the board file there. But yeah, I do think I want to spend some time writing nMigen here on streams. So that will be hopefully interesting. Anyways, so I think that would be it for now. And I really appreciate you all being here, as always. Thank you very much for like being here, supporting this, and learning together with me. I hope you learn stuff here and you enjoy these streams. Let me know if you have any suggestions. We have the chat on Discord that is being linked here on a regular basis. Important thing is if you have some like a blocker in your browser, you might not see the embedded Discord invite like widget on that page. So you might need to like enable JavaScript or like disable a privacy blocker for that one page for a minute to get the correct link. I didn't realize that this was slightly problematic for people. I would like to change that so that it is easier and people feel safer. But yeah, just FYI, that's how the Discord invite link works on there. Yeah, so join our Discord, talk to us. The forum move that I mentioned before will still happen probably, like, I hope soon. I will come around to do the administrative janitorial stuff there to make the discourse forum for the whole 1bit² community and not just for iCEBreaker. Otherwise, feel free to drop your messages also in the forum if it is related to iCEBreaker. Yeah, so that... yeah, again, thank you everyone who is subscribed to this channel over Twitch. The donations really help. The support really helps to make these streams possible and pay for the gear and justify my time working on this. Same goes to all the wonderful and generous Patreons that are supporting these streams. It is all free, obviously. If you don't have money, don't worry. I appreciate you being here. But if you have a little bit cash spare that you want to send this way, and I earned your trust that it is worth it to support these streams, I would really appreciate it. And as always, I would like to give a shout out to a few individuals that are the supporters of this stream, and that would be Aki Van Ness, Jamin, Brennan Ashton, Ben Vennick, Drew Fustini, Edward Borden, Go Jimmy Pie, Jeff Wang, Jordi Parky Rodriguez, Kelly, Matis Schmiedle, Matis Pritchett, Miha Benovets, Sean C., Tom Keddy, and Sid Price. So thank you very much, everyone, and thank you for being here. And yeah, as always, if you have been, thank you for watching. Bye!